Hello, everybody. Can you hear me?
Yes.
Okay. Today, 14th of June, I review with you the project progress. Okay. So, because last lecture was last Wednesday, June 9, next class will be a review for final exam, and you need to handle assignment number 2. June 21, project presentation, and submit the project report. The project report itself will be the presentation, save it in PDF format. I will post a folder on Moodle where to deposit your presentation. June 23 is the final exam. Yesterday, I posted on Moodle some remarks or observations regarding your respective projects. And today I need to review with you your projects, what you have done, and help you to improve the projects. So before I start, do you have any questions? So who can start? Who can start? If any group can show me his preliminary results. Can any group show me his preliminary results? So I got Anjali Patel and friends. Anjali Patel and friends, I recommend them to include the title and argue the choice of the model, because they have submitted, they have proposed one single model. They say they think it's the best, but they have to prove it. To prove it, they need, so Anjali, are you there? Jason, Amir, Nicholas.
Yes, sir.
Okay, is Amir speaking?
Yes, it's Amir.
Okay, Amir, please, Amir, include, if you believe your model is good, you need to prove it. To prove it, you need to use another model and compare the results. So I recommend you do not be highly confident, and it is strong to say, I believe this model is good one. Just tell me, or just introduce the projects as a comparative study between 2 or 3 models, and compare the two or 3 models, and show which is the best one in terms of some statistical metrics, like just R square, like standard errors or standard error, standard deviation of the errors, and so on. Okay.
Okay, sir. So, because as you said, we find out that we're not so sure if this is like the right model. So maybe if we choose like 2 or 3 models and compare them, that would be good, and we choose the best one.
Yes, exactly.
Okay, perfect. Okay, thank you very
Yes,
much.
exactly. Do not seek one single model, but use 2 or 3 and compare them, and be neutral. Be neutral at the beginning. Okay, your goal is to compare 2 or 3 models in the task of topical investigating, and compare the models. Be neutral and do not engage yourself too much.
Okay, sir. But we have one thing is that in our data, we only have 2 variables. Like we don't have a lot of variables. Is this a problem, or it's okay?
Then okay. So you can regress y on lagged values of x, and also on lagged values of y. Understand?
No, what do you mean also on y? Like, for example,
You have one single y and you have one single x.
Yes.
Okay. Now, can you see what I am writing?
Yes, yes.
I will write in blue fonts. Okay, this is y at time t is equal to beta 0 plus beta 1 multiplied by x at time t. Okay, this is basically your model. Okay,
Yes, exactly.
this can be the basic one, but you can extend it. You regress y on you regress y on xt and xt minus 1 at time t minus 1. We call this lagged value of x. Okay?
Okay, okay, yeah.
Another extension of this, you may add, for example, plus beta 3 xt minus 2. Or you can do the following as a third model, for example. This will be yt.
Oh, okay.
Okay. Or this is as fourth model. You regress yt on constants plus beta 1 xt, beta 2 xt minus 1, plus beta 3 yt minus 1, lagged value of x, and one lagged value of y. Okay?
Okay, perfect. Thank you very much.
Is that clear? But
Yes, yes.
stick on that one only, it's not informative. So conclusion you draw from this model are not informative because they are not compared to some reference models. We cannot say that this one is good or not good if you cannot compare to others. So the other models you can bring to the table are these three, for example. Pick one or two or three and compare your results.
Okay, perfect. Thank you very much.
Finally, you can conclude and show which model is the best to explain variations in YT. Because your goal is to explain variations in YT or to predict YT.
Okay, perfect. And then we have to argue why it's the best model, yes?
Yes, you argue based on just R square, RMSE if you are doing forecasting, based on standard deviation, standard errors. So you got many statistics. Okay.
Thank you very much. Yes.
Other question, Mr. Amir?
No, this is all for us. Thank you very much.
Okay. So, and by the way, if you do have, for all groups, for all teams, if you do have some intermediate results that you want to discuss with me, please drop me an email. I am ready. I will be happy to meet with you and discuss with your all students, for all the teams. Mr. Joseph, Andrea, Jason, and Justin.
Yeah.
Yes, we have had a meeting on Zoom, and I, as my my observation is to consider my suggestion about what we have discussed previously. If you do have some result to show me, please go ahead.
Yeah, I showed you during our meeting, sir, what I have so far for our project.
Do you want to show me something right now?
Well, I haven't really updated anything else. So what I showed you is the most recent version right now.
You can do it right now?
Yeah, sure. I'll show you.
Yes, please. Please share.
You have to give me a screen. I could share my screen, sir.
Okay, share screen. Allow participant to share screen. Okay, you are allowed to share your screen.
All right, so this is what we have so far. We had an initial model with 8 explanatory variables. We did some variable selections, all possible regression, backward elimination, stepwise, and forward selection.
Andrea, please, can you enlarge, please?
Yeah.
Okay.
Yeah, so we had an initial model with 8 explanatory variables, and then we used some variable selection techniques to reduce this model. So when comparing the models, we see that the best one is when we used all possible regressions, backward elimination, and stepwise, because it yielded the highest adjusted R-squared, the lowest standard error, the lowest malus CP. And all the variables are significant, where the other ones, not all the variables were significant. So we have our best model right now. So now we're just gonna check the assumptions and fit the curves.
Yes, very important to check assumptions. Otherwise, your investigation or your data modeling is incomplete.
Yep, no problem.
Okay. Other questions, Mr. Andrea?
No, that's it so far.
Okay, thank you very much, Mr. Andrea.
Thank you, sir.
Alexandra Thibault, Jacob Conley, and Megan Vondet. My recommendation, my observation, my remark is to consider my suggestion. My suggestion from the last meeting on Zoom. So tell me if you have updated your project accordingly, please. If you did so can you share with me, please, your results? Alexandra, Jacob, and Megan. Are you there? Okay, Jacob, Megan, Alexandra, they are not there. Amanda, Jennifer, and Tiffany, are you there? Amanda, Jennifer, Tiffany. Okay. Justin, Frankie, and Anne-Sophie. Are you there? Justin, Frankie, and Sophie. Okay. Robert, Adib, Rita, and Q. Are you there? Robert, Adib, Rita, and Q. Are you there? So, Munir, Naira, and Maria.
Yes. Hi, sir.
Hello. My remark, very nice topic, but please do compare, use use 2 or 3 models, predictive models, for predictions. Okay,
Yeah.
for predictions. Do you have did you have updated the results your projects according to our last meeting on Zoom? Because I think we had a private meeting on Zoom.
No, we didn't.
We didn't.
No. That's why we were waiting on the comments to start. Like, I see some people got meetings, but we didn't.
Ah, okay. But I had discussed with you your project.
We did discuss, but we
was
discussed for
in
assignment
class.
1.
Yeah, and we discussed it in class too, like really quickly at the beginning when we were selecting the topics. Like, I had written out what could be potentially for that topic, and we asked questions, and that was it. Like, we didn't really have a
Okay.
private meeting.
Okay, can we do it right now, please?
Sure, yes.
So please share your documents.
The proposal?
No, the
Or-
improvements.
Well, that's what we're saying. We didn't start because we were waiting on you to give us feedback on how the proposal was, if it was okay or not.
Okay, okay, share the proposal and let's discuss.
Okay. Oops, sorry. I zoomed in too much. Do you want me to go to what we were planning to do on the methodology?
Yes,
Yeah.
what is y, what are x's?
Yeah, so we were planning basically, we're gonna look at the fluctuation of prices for avocados, and so our y would be the price, and then the x's would be the years, like the same prices for different years.
Do you have the plots? Can you show me the plot of the evolution of prices of the
Yes. So this one was the prices, they keep going up and down for different periods, and we wanted to see which period would be more relevant to predict the last year. Since we have data, we could compare the accuracy of that.
basically when you do forecasting, use 80% of the observations. The first 80% of the first observations for inference, for estimation of your B's, okay, of estimation of the model, and the remaining 20% for forecasting. Okay, then when you got the forecast value, you can compare them to the true ones to get, for example, the root of mean of squared errors. And the model with the lowest root of mean of squared errors is the best one. You understand?
Yeah.
Okay. Now it turns to be this the evolution is cyclical, is seasonal. Okay, because we got ups and downs, ups and downs, ups and downs, ups and downs. It's highly volatile. So in forecasting task, we usually use 80% of the first observation for training or for estimation of the true model of the model that will be used for forecasting, and you test it, you validate it on the remaining 20% of observations. Is it understood?
Yes.
Okay. And so the y will be what? X will be what?
Y is the price, and
Okay.
then X is the price of the previous years.
Okay. Okay. Can you stop sharing?
Yes.
So this is your y is the current price at time t. B0 plus B1. What is your X? Is price at time t minus 1.
Yes.
Okay, like that. This is your basic model. Okay? So try also these models. Regress 1 on additional lax values of PT. You do not have choice because you do have only one observation, only one variable.
So it would be like t minus 2.
Yes, exactly.
Okay.
B2 plus t minus 2. But this is what we call autoregressive model.
Okay.
Autoregressive model. Yes, this is what we call the autoregressive model. If you take BSCA 477 next fall, I will teach you this kind of autoregressive models and moving average models. And it will be in class, not on Zoom next fall. So we will meet each other. B3, and this is your B3. So you regress, you regress PT on constants, B1 PT minus 1, B2 PT minus 2, BT PT minus 3. You can go over, you can extend the model to BT minus 4, BT minus 5. So, but use stop at 3 or 4, no more than that.
Okay.
So we call this we call this is out of scope of our class, but I'm just telling you, we call this autoregressive model of order 1. This one is of order 2. This is of order 2, and this one order 3, and so on. We call this kind of model autoregressive model, and we call it AR. This is a kind of models you will see in 477, BSc 477, if you are willing to take this course. And how to choose the best one, if you use this in your project, use the best one based on just R square and base it on standard errors of the regression. But once you will take, if we are in BSCA 477, the identification metrics will not be just R square or standard error. There will be Schwartz criterion, Akaike criterion, and -2 log likelihood, like we did for probits and logits. Okay?
Yes.
So this is your basic model. So Munir and friends, this is your basic model, and compare it against these two models. So your basic model will be AR1, and for comparison purpose, use, for example, AR2, AR3, AR4, maximum AR4. Do not go over that. Okay?
Yeah.
Okay, thank you.
And use just a square, because you are increasing number of inputs going from 1 to 3, and use standard errors to pick the best one.
Perfect. Thank you.
Okay? For your information, you may use Akaike, Schwartz criterion, and -2 log likelihood, and you need to minimize. So the best model is the one that minimizes. So minimize minimize. Okay?
Yes.
This model should have minimum Akaike or minimum Schwartz or minimum Maestro log likelihood. In general, the best model has the minimum of all three of these parametrics, of these metrics, performance metrics. So in conjunction with adjusted R-square and standard errors of the regression, okay, use the following. Okay?
Yes.
Please take note. Please take note.
Yeah, we're
Yeah.
writing it all down.
Okay.
Also, I just wanted is the presentation to be like 10 to 15 minutes or 10 minutes?
15.
15? Okay, thank you.
Not 50. 15.
No, yes. Yes,
15.
15 minutes.
1.5.
Thank you.
Thank you. Other questions?
I actually have a question, but it's regarding assignment 2. Can we ask you now, or should we ask you at the end of the class?
Yes, you may ask right now. Yes.
Yes, it's because for the last question for section 6, when we ran the logistic regression, it's asking to test the overall significance of the model. And we weren't sure if we should take the p-value from the table called Testing Global Null Hypothesis, or if we should take it from the, let me give the name, Hosmer and Lemshow goodness of fit test.
Okay.
Yes, exercise 6, question 3 is test the overall significance of the model.
Okay. This one. 3.
Yeah.
So what we are doing here, significance, this overall significance, Hosmer.
Hosmer, okay, perfect.
Okay.
Thank you.
Thank you.
Logistic regression. Yes, logistic regression, Hosmer. It has also F statistic. F statistic.
Mm-hmm.
Okay, F statistic.
Okay, thank you.
But
I didn't see the F statistics for the Hosmer test. I don't
yes,
know
this is what I'm going to check.
because I only saw the p-value.
For logistic, there is Hosmer is for probit and logits. For logistic, you need to check F statistic.
Oh, okay.
Then, sir, I don't know where to find the F statistic then.
Yes, let me check this.
Or it's the Wald test, no?
Sorry?
It's the Wald test, W-A-L-D.
Wald test, exactly, Wald test. Is Wald test.
Okay, thank you very much.
Let me check this, please, before. Okay, it's Wald test, exactly, thank you. It's Wald test. Is this one, Wald test. Do you see?
Okay.
Do you
Yes,
see?
that was the one we were referring to previously, like the table testing global
Exactly.
null. Okay, we
This is
just
Wald
went.
test. It's like Fisher statistic, except that Wald test is based on chi-square. Fisher is testing the null hypothesis that all coefficients are equal to 0 based on F distribution. Okay?
Okay.
This is when Y is continuous. When Y it is continuous, it is categorical or binary, then we use a test similar to Fisher, testing the null hypothesis that all coefficients are equal to 0, and this test is performed by applying Wald test. And Wald test is using chi-square. Instead of using Fisher distribution, it is using chi-square. So look at Wald. If Wald p-value is less than 5%, then reject the null hypothesis that all coefficients are equal to 0, so the model is not good. Reject the null hypothesis that the model is not good, it's not significant, and accept the alternative one that the model is significant because at least one of the coefficients is statistically different from 0. Okay?
Okay, thank you so much.
Thank you. Now, so Rui and Yu Chao. Rui and Yu Chao, are you there? Okay, Rui and Chao are not there. Let's talk to, yes, we should talk. Vivian and Xiaowin. Vivian and Xiaowin. Are you there? Vivian and Xiaoying. Okay. Yuji and Ting.
Yes.
Yuji and Single. Are you there?
Yes.
Thank you. Can you share with me your documents, please?
We have some questions because I sent you an email about our project and we're not really understand our data because we found data is too general. I mean, like it's too large. There's a big data.
So it's very easy. So your project is now is becoming very interesting.
It's too big, this data, and then we have so many numbers there and we're not really understand that.
Okay, can you first share with me the documents and the Excel file?
Can you see my screen?
Oh yes, okay.
It's like really big data, and then there.
How many observations you got?
I don't know. Here have.
Actually, we have maybe 5 or 6 variable over observation as the rest of the year. We choose some part of the data here.
Because we know like those are the independent variable, but I mean like after they had same thing like explained by logic GPD for, and then there's different numbers. And
So you have a large number of explanatory variables to investigate, right?
Yes.
Yeah.
Okay. And now, how many numbers observations? Can you scroll down completely to down?
Yeah, I guess it's 150 oops.
Okay, this is not big data. How many inputs? How many X's? 20?
From here, what is upper whisker, lower whisker?
Sorry?
Are those the independent variable, or because we don't really understand what is upper whisker or lower whisker?
Upper whisker, lower whisker, they are the distributions of your Y, Okay, showing, for example, upper whisker. If you look at the box plot of the distribution, upper whisker is the down limit is the bottom of the box, and upper whisker is the up limit of the box.
So it's not independent variable.
They can not appropriate to be independent variables.
So I guess from here, large GDP and onto here. But the next one was explained by large GDP and explained by social support, and they're the same, but the number is different.
Oh, okay.
So we're so confused. Like, I guess from here, like those 7 are the independent variables for the lighter score.
Okay. Have you any indication about what is meant by explain it by?
Sorry, there's no noisy. I didn't really hear it.
Do you have any explanation or indication about what explain it by means?
Actually, no, they only have a little bit of description of the whole data. So that's the reason why we are confused about that.
Okay, so let's assume that explain it by, this is the description, okay. Let's assume that description.
So we're using this data. And then
Yeah, this one.
there's only some explanations here, and we didn't see anything else.
But you do not have description of the variables.
No.
Okay. Do you know what for your project, what is Y? Show me Y. On Excel file, show me your Y.
Yeah. The country's name?
No, cannot be country name.
What's the mean? Why the dependence?
Yeah, the Y is the dependence, and the other, the dependent, okay, ladder is the dependence.
Yeah.
Yeah.
What is ladder score?
Ladder score is a score to evaluate the happiness of a country.
Okay. Okay, so let's consider ladder score being your Y, and all others are X's. So since you do have a large number of X's, go simple. Compare all 3 methods for variable selection, backward, forward, and stepwise, okay? Pick the best model under each one, and finally, pick the best model based on adjust R-square, based on standard errors of derivation, and check if all p-values are significant or not, and also check for assumptions from the best model. You understand?
What you mean best model? You mean like
if you run backward selection, you get the best model from backward selection. When you run forward selection, you got the best model from forward selection. When you run stepwise selection, you will get the best model from stepwise selection. So compare these 3 models and pick the best one. Once you pick the best one, check for regression assumptions regarding normality, constant variance, linear specification, absence of multicollinearity, absence of serial correlation errors, and so on.
Do we need to like do like one is a full model and then the other one is like remove two independent variable and then to compare them?
Can you say again, please?
I mean, do we need to do like two model and then compare them?
Yes, you are comparing model. The model selects by stepwise, model selects by forward, and the model selects by backward. Compare the two approaches.
Okay.
When you get the final model, check the assumptions of the final model.
Okay. Okay. So we're gonna give a conclusion like which one is the best.
Exactly.
Okay.
With a conclusion that comes with strong arguments, please.
Okay.
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 Yeah.
Yeah, okay.
Then.
If you need to meet with me, drop me an email.
Yeah, I actually sent the email on Saturday, last Saturday, and then I don't know if you received it.
Maybe I didn't pay attention. Maybe.
Okay.
Normally, I respond to all emails. I respond to all emails.
Yeah.
I cannot skip an email. Normally, I answer all emails. It is the first one it happens to me. Yes. Oh, yes. Oh, yes. I read it. Okay, I read it. Yes, I read it. And I wanted to answer you, but my answer was in the kind of giving my feedback to all students regarding their proposals.
Okay.
Okay.
No problem.
So this is why I wrote, okay, go ahead.
Okay. But now you answer, so if we have others, I will send you email.
Yes. Yes. So do run your models, compare them, then get back to me for discussion.
Okay.
Okay, drop me an email.
Yeah, thank you.
Okay. So I went over some people who missed the meeting. Who has questions, please? Who has questions, please ask me. Who has questions regarding his project?